Hello everyone, this is Sriman and welcome to Genius Math Minds. In this video, we will see about one of my favorite topics in the whole of mathematics, that is Venn diagrams. Venn diagrams are dealt with, or Venn diagrams are for set theory concept. So this is the diagrammatic representation of a set. A set is diagrammatically represented through Venn diagrams. So that's what Venn diagrams are for. The upside of the Venn diagrams is that you don't need to mug up or you don't need to remember any formulas in sets. You can just do the calculations with these diagrams. So that's why Venn diagrams are very helpful and very interesting to learn too. And that's why that is my favorite concept, one of my favorite concepts in mathematics. So first, what is a Venn diagram? So this is the basic representation of a Venn diagram. This has two sets, A and B. And this universal set combines both A and B, and also it may contain some other values as well. So we usually represent a set as A. Let's say we have 1, 2, 3. And we have B, 0 and 5. So what will U can be? One important thing about U is U must contain the elements of both A and B. So we can have 1, 2, 3, 4, 5. This can be U because it contains all the elements of A and B. We don't need to care if it contains any more elements than A and B. So just U is the universal set, so it must contain the numbers in both A and B because those are the sets inside this U. So now what A is this circle right here and B is this circle right here and U is this box right here. So this is the basic representation of a Venn diagram of two sets. So here we have this thing that is, it is in both A and B. If there is any elements that is in both A and B, it will be in this region. If it is only in A, then it will be in this region. If it is only in B, then it will be in this region. So if there are common elements, then they will be in the middle region. So next we have disjoint set. If there is no common terms to both A and B, then we can represent it as this. So A and B, there is no intersection terms right here. So now we will see the intersection, union, difference of two sets by Venn diagram. So what is A intersection B? A intersection B gives the common terms. So how we represent it is just the basic representation of a two set Venn diagram, that is A and B. A intersection B is represented as, we just need to shade. So shading is the main thing by representing a Venn diagram. So A intersection B, just the common terms. So we just shade the region between A and B, or the common terms, that is shaded in the red region. So this is the representation of A intersection B through a Venn diagram. So next, A union B. What is A union B? A union B is the terms in both A and B also. So A union B is just the region A and B. Now we don't shade the region U because U is not the same as A union B. A union B is just all the elements in A, all the elements in B. Those together are A union B. So all the elements in A, all the elements in B. There won't be any A union B elements that is in U. So if an element is in U, that does not mean it should be in A union B. Because A and B elements are different from U. But A and B should be in U. So that's one thing. So next, A minus B. So A minus B means all the elements in A that is not in B. So all the elements in A are represented, but it should not be in B. So the intersection term is left out. So that's why A minus B is represented as this. So next, A dash. Now this is a very important concept. A dash is all the elements in the universal set minus the A. So A dash means U minus A. So all the elements in U must be shaded, but except the A element. So just leaving the A region away, so shading all the other regions. So just leaving the A region and shading all the other regions. So that is A dash. This is called complement. So complement of A, that is everything other than A. So that is complement of A. So now that's two sets. That's when we have two sets. If we have just one set, then we can represent it as this. So just A and U. If there is A dash, just shade all the regions here and don't shade the region A. If it is just A, just say the region A. So that's it. Now for 3 sets, this is the Venn diagram for 3 sets, A, B and C. Now an important thing is why it is represented as this is, there must be a region where it should be just A and B. That is this region right here. Here there is no C, only A and B. But A and B intersect here. And there is a common region to all A, B and C. That is the middle region. So there A, B and C common to all these sets represented here. And there is a region where B and C is common to not A. And another region that is common to A and C but not B. So this is the representation of a 3-set Venn diagram. So why these Venn diagrams will be important is you don't need to remember formulas relating to sets, because they can be implemented through Venn diagrams, which will be easy for you to understand or diagrammatically picturize the images so to get a new answer. So that's why Venn diagrams are important. These are the basic Venn diagrams. We usually use 2-set Venn diagrams or at most 3-set Venn diagrams. 1-set Venn diagrams are not that important because there is only one operation, that is A dash or the complement of A operation. So that's about basics of Venn diagram. In my next video I will show how to implement the formulas through Venn diagrams. So that's it about Venn diagrams. Thank you.